Well, I have been playing with this wheel, setting up my tenon auger, getting ready to cut the tenons on the end of these spokes so I can put the fellies on. And it's been a bit of a struggle, and I'm going to walk you through some of the steps that I've been encountering. I think I've got it lined out, but I found that I have another little kink. Let me show you what I mean. Well, this is the Tenon auger that I used. I designed it for an 1 3/4 tenon. Well, the blade that I had made when I did the borax wheels was this blade here. But as I began to use this tenon cutter on these logging wheels, this blade was not quite wide enough, and so I was running onto a shoulder on these spokes that was not getting cut, which was actually stopping the cutting progress. That blade was actually about 1/8 of an inch short of catching these corners, and it was just enough to slow it down to where it just stopped cutting. So then I changed from this blade to this style of blade. So you all know by now that I use these heavy-duty horseshoeing rasps a lot here in the shop for my woodwork. I have a real coarse side and then a finer tooth on the other side, teeth down both edges. That's what I use. I have lots of these that are no longer sharp enough to use in the shop. So these are what I use actually to make my blades for my new tenon cutters. So the first blade that I made that was wider, I took right out of the center of one of these files. And I made a blade on this configuration out of the body of this file. That blade was this blade, or what is now left of this blade. When I set this into the cutter, I had too much of a bite right here. It has to be set just right. Well, I had too much of a bite and I broke it. So then I went back to make myself another one. So I got another file and I cut off the tang of this file, and so I chose this section to make my next blade out of right here. You can see the teeth starting here, and this blade set right in this position. That's where this blade came from. So I cut it out, made it fit, and it would not work because this portion of the file did not have the quality of temper to it that I needed, and I couldn't keep an edge. Even went through the process of tempering this, which I've done a number of different times, but yet still it would not keep that edge. So this is now my second attempt. The first one I broke. The second one would not keep an edge. So now my third one is actually one that's in this tenon auger that works. And this came right out of the center of this file where the teeth are at. You can see where I've filed off the teeth. This blade now works. It's enough wider that it'll catch that outside corner of these spokes. So on this framework that holds my tenon cutter to my wheel stand that the wheel is sitting on, I put a wood post that will help support this lower spoke in position as I begin to cut the tenons. Kind of about like so. Well, my goal is to have all these tenons in a line so that I can put all these fellow sections on. But as these spokes come out of the hubs, the bottom spokes are too low, the top spokes are too high, so I'm having to adjust these into the plane where they're supposed to be and not where they're at now. So that's why I have this 2x material on top, with this clamp here. You can see this spoke will move, but I'm putting the resistance of the two high spokes against the one low spoke and bringing this low spoke up into its proper position. So when it swings into place over this post, I can pull it up to where it needs to be correctly and sit on top of this post. And then on each side of this post I have a little metal strap that I'm pulling up, and I have one on both sides so I can maintain the proper height, and then this keeps it in the correct position from sliding or shifting side to side. So when I shifted the point on these spokes, it now gets it there to where it's just really close to where it will start on the tenon cutter. So through this whole process of figuring this out, I do have 3 tenons that I have cut. The outer part of these is when I was playing with my different cutters, and they're a little rough. This final 2/3 is where I have my blade in my Tenon auger that it is now, and it comes up and cuts to this shoulder to the correct angle that it needs to be. So I now have 3 tenons that are cut. The thing about it is, it took me 5 hours to get 3 tenons cut. But I think you can see this tenon is not cutting straight with the spoke, but this tenon is heading right toward the center of that hub where it's supposed to be. So this angle is all working out well with how I have myself set up. So through the process of shifting the position of the center of this spoke, moving it a 1/2 inch off to the side, I had one side that was maybe a little shallow. So you may have noticed in maybe the last video, I'd put some auto body filler on that shallow side, trying to build it up to help to keep that tenon auger in place. This really doesn't add anything structurally to the spoke. In my thought process, all I was trying to do was to help keep that tenon auger centered up. It would actually go past this filler and start cutting back in here. And we see this on these 3 tenons that I've already cut. You can see on this spoke that it really didn't have any effect at all. The tenon cutter is held in position, and then when I have this whole spoke on the block and caged in by these 2 straps, this spoke is really held in place enough that this was an unnecessary attempt, so I really didn't need to add that, and it probably won't do that on the second wheel. Structurally, this whole body of the spoke is where the strength is, and it just needs to come out to where it'll make contact on the tire. The bulk of the compression is going to be on this shoulder, and then whatever I can get on that tip. If I were cutting these more freehand, building up that lower side would be more of an issue. But since I decided to contain my spoke so well and my drill press is held pretty firmly, it really wasn't necessary. So the last step that I ran into, kind of a roadblock, was actually in my cutting process, and I'll show you what happens here. You can hear the change in the pitch. So you can hear the amount of power it takes out of this drill to start cutting this whole shoulder full thickness. So this one was actually continuing to cut. On a couple of the others, it would stop right where the taper hit the straight portion of the spoke. So then I took and thought, well, if you like it taper better, maybe I could do all this process and continue to take some more material off. Well, that does indeed help removing more material so that I can continue the cutting process. So as I put my measuring stick to the center of the hub, I have a placement where my shoulder needs to be, so I put a mark on the edge of my spoke where that needs to be. So then I can continue the process of cutting right down to that shoulder mark. So that doesn't do too bad a job. It leaves a pretty common, typical style tenon on a spoke. So my plan is just to do all the bottom spokes in this manner. Just move my block from the top spokes. And I'll bring the next spoke up into place so that everything is uniform, and do all my bottom spokes, and then I'll do the same thing similar on my top spokes. I'll set this down into place where it's in the same position and continue to cut my tenons. So now that makes my fourth tenon, and as it would be, I was going to demonstrate to you firsthand how much difficulty that drill was having cutting these tenons. And this one actually cut it pretty well. The first three just fought me and fought me and fought me. I would come up to the end of the taper, I'd have to re-taper more, come up to the end of that taper, and then finally come down to the final mark where my shoulder needs to be. So I was contemplating, how can I remove more material before my tenon cutter actually has to do its work to come up to that final mark? And then it dawned on me that there's already cutter that is designed to do that, post and rail fences, those style of tenon cutters. So I did look around and I found a post rail tenon cutter that will cut a 2-inch tenon. And my tenon cutter, I want 1 3/4 inches, so that will remove the bulk of the material, and I'll fine tune it with the tenon cutter that I built. But that won't be in until the end of the week. So I may just try a few more and see if they continue to be workable like this. But I think maybe that other post rail tenon cutter might take some of the work off of my drill. In a previous video, I think I mentioned that the RPM on this is 450. I looked closer at the tag on it and it's actually 250. So it's a pretty powerful drill. We'll see how the next one goes. Well, that's a little more like the first three. You know, by the time it gets up here to where it's full faced, it really starts to work that drill. So that was more true to form, that the same tedious process I was running into on the first 3 spokes. Just the difference in the hardness of wood. That's why I think I'm going to wait till this post rail tenon cutter shows up, that I can take it down to 2-inch, take off the bulk of material, and then do my final cut to the 1 3/4 and come up with a square face. So since I've got a little time while I wait for this other tenon cutter to show up, thought I'd use this time to maybe space out the holes that are going to be in my fellow sections, get those lined out, and maybe even get them drilled. So when I sawed these out, I did make them a little extra long, and my pattern is even a little extra long as well. So I thought I'd just mark out these ends where they could be trimmed off, and just allow for the maximum length. Figure out where the end of my fellies could be. So between these 2 end marks, I'm just going to find my center. So I'll take my traveler for that and find out what we have. We are at 1 revolution plus another 6.5. So not even having to do math, we're going to go half a revolution, which would be 12 inches. In there's 12 plus 1, 2, 3 1/4. Half of 24 6.5. That should be our center. So we know this face is going to be our outside diameter. We need to know what the inside diameter on the inside of these fellies are going to be. So we're 120 inches out here. We have 4-inch thick on our fellies. So off of the 120, we're going to take off 8 inches, 4 for each side. So our inside diameter is going to be 112 inches. So we are at 112 inches times pi, 3.1416. And we're going to divide this out by 24 spokes. So we have 14.66. This would be the distance, 14.66 inches between spoke holes. So 14.625 is 14 5/8. So this is going to be a strong 5/8, but not quite 11/16. And that's easy enough to mark out on my traveler. So if we can pick this up, here's 24, which is the same as 0. And we're going to go in 1-inch increments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14.5, 14 5/8. I'm just going to put it to the strong side of that 5/8 mark, right about there. So I know our style of math frustrates many of you that are used to the metric system. I'm not. So to take 14 5/8 and divide that in half, we're just going to, 14.5 is 7, 5/8 and half is 5/16. So the 7 5/16 will then become my center mark. So here's my 7, 7 5/16. I put that on my center mark. And I can go back to my 0. That will become my first spoke location. Roll back to my center, and then on the other side at my 14 and strong 5/8, that will become location for my second spoke. And I'll just accent them so they are a little more visible. And then the center lamination mark is going to become my center. And that's where I'll drill my 2 holes. So I do like to drill a test hole to make sure my bit fits my tenon. It's a little snug. I may have to sandpaper that just a fuzz, because that's a nice tight fit. Sometimes I put dry bar soap on there. That'll lubricate that right up. So I have several bits that I've made. And you can see from the marks on them that I've made these also from old used horseshoe files. And I have ground them to different widths. So I have a couple that are a little undersized. This one is 1.5 inches. This one is 1.75 inches. This is the one I'll actually use. And this one is about 1 inch and a strong 5/8, almost 11/16. But I just custom fit these to whatever holes I have needed. So this is the jig that I use to drill the spoke holes for my large fellow sections. So on this milling table, I can adjust right to the center. I don't want to move side to side, that is set, but I can move in and out. And I'll just clamp this to my back fence. And I can bring that right to the center of my lamination, and that will line up where my spoke's going to go. That's as far as I can go for depth. I'm just going to drop my bit just a bit. That'll get through our 4 inches. So since our spokes are 2 7/8 on the square, on the diagonal, we're just about 3.5 inches. So we'll be 3.5 inches this width as well. Putting these bevels on between the bevels will allow us a strong 4.5 inches. So our 3.5 inch spoke should fit just right about so. So these felly sections will also get a 5/16 bolt that goes on each side of the spoke. Pretty common for wagon wheels. I'll drill those, but I'm going to do that down the road. So even though I've got a few more days to wait for this other tenon cutter to come up, I've got enough stuff to still fill my time. I'm going to prepare the rest of these fellow sections. Anyway, this is kind of the process. Appreciate you following along. Thanks for watching.